Okay, today I'm going to go through the rear shock. I'll do the rear shock first and then I'll do the front shock afterwards, mainly because I'm checking the oil level in the shock tubes in the front. So I've done the rear. I'll walk you through what happened there after my ride. So before I did any preload adjustments, this is my original equipment in the center of this table. So it was a 6 kilogram per millimeter spring. It's got the standard valving in the shock, and I estimated from a previous video it was about a 3 millimeter preload, which was 18 kilogram spring. So the bike sag was 60 millimeters static, and then race sag, which is your bike plus rider, was about 115. So once I fitted the 8.5 kilograms a millimeter spring and upgraded the valving, I worked out I needed a similar distance on my adjuster to get the right preload. So the preload I was aiming for about 80 millimeters on your race sag. So when I actually measured it, when I came back, I got 57 millimeters for static and 95 millimeters for race. And so really, I didn't achieve what I set out to achieve, and I thought, why is that? That seems strange. I'd done all the calculations, I'd measured the distances and set it. So when I plotted it out, I found that I'd only actually put about 5 kilogram shock preload on this bike, and I needed about 30 kilograms for the spring. So probably what I think's happened is there's some slack in the system. So you've got some slack in your linkages, you've got some non-linearity in your linkages, and the initial preload I put on was basically taking up the initial slack. And so if I go to the next slide, you'll see here, so this is a slide of rear wheel weight along the bottom. My spring weight is 8.5 kilograms per millimeter, which is the blue one, and it's a non-linear curve, remember. And then my rear wheel deflection is up the left-hand side. And so the 2 points I measured were the 105 kilograms, which is the static bike weight on the rear, and it deflected about 57. And then if you look at my race sag, it was about 169 plus the bike, and it deflected about 95. And you can see there where it intersects, it was only about a 5 kilogram, it was actually a 3 kilogram rear wheel a 3 kilogram rear wheel weight, which is about a 5 kilogram shock preload. So the green point on this curve is where I actually want the ideal sag to be. So about 30% of the 240 travel is about 80 millimeters, and I'm about 160 or 170 rear wheel weight. I've actually measured it this time. I actually put the bike on scales, and so I've got about 170 kilograms rear wheel weight, sorry, for an 80 millimeters rear sag. So you can see there I have to move this curve about 15 kilograms to the right. So I needed more preload on this shock. So my initial preload was really just taking up the slack in the system, and I need a bit more preload on this to get the sag right. So here's the challenge today. I'm going to adjust my rear shock preload, and you can only get into it from here. So I've still got the airbox in, so you can only get into from that little point through here next to your reservoir for your spring, or your shock rather, or you can get to it from under there. So what I'm going to try and do is knock the top spring loose from here, and then I'll jack it up on the motorcycle lift, whatever it's called, the motocross lift, and then I'll see if I can adjust the preload. Now I did need about, I think it was 3 or 4 millimeters, 4.4 mil, I can't remember what it is now, but anyway, I do need to adjust that preload a bit more. I've only got about 5 kilograms on it, and it was a little bit springy in the ride. It was a lot firmer than it was previously, but it was a little bit springy, and I couldn't decide if that was my compression or my preload. So what I'm going to do is I'll just adjust the preload to get my 80 millimeters. So I'm setting about 97. So I'll knock the top off, I'll adjust the bottom ring, and then I will measure it to see I'm right on the zone. So I'm looking for about 80 millimeters preload for this spring. Okay, let's see how I get on. Okay, as expected, you can't get anything into anything with the shock like that. So what I'm going to try and do is I've measured the distance between the top of the top of the spring and the top of the locking nut, and I know I want to add about 20 kilos to this spring as a first going in position, and that will give me about 4 mil, whatever the number was. So what I'm going to do is I'm going to work out what distance I need to add 20 kilos. So it's about 8.5 kilos a millimeter. So 20 divided by 8.5 is near enough 2.5. So I'm going to add about 2.5 mil to this distance. I'm going to use my punch to punch the spring nut down, because I can't get a C-spanner until I've tried. You can't get it turned. And I'm going to knock it down, and then I'll test what height it is. So let's give that a try. So just let you know, the only way you can do this if you want to use a C-spanner is probably take the air box out and get into it from behind. So this is a sort of it's a bit of a half-arsed job. Because I don't want to take the airbox and everything out. So I'm going to see if I can do it without taking the airbox and everything out. If I can't, it's stripping everything down. So let's see how I get on. I added the required preload. So here's about 20 kilograms rear wheel preload. And remember, the ratio is about 1.8. So you end up with about 36 at the shock. And you can see there, it goes through my race sag point. I actually ended up 169 kilos and 78 millimeters. And my static sag is 105.37. Now the static sag surprised me because it's not falling on the line, and I think that's caused by two things. One, you've got a non-linear system in terms of force, and two, you've probably got some stiction and things like that in the shock when it initially kicks off. And so I'm happy with that curve. I'm happy that I've got my race sag almost exactly right. It should be about 80 millimeters, but it goes to 78, which is fine. 2 millimeters I'm not caring about. So we'll look at the final result now. So again, similar table. The original equipment there, I had 60 millimeter sag static and 115 race. And now I've got 37 static at the back and 78 race. So I've lost about 37 millimeter sag from the race perspective. So that's pretty good. So just remember, linkage is a non-linear force on this thing. It's a complicated linkage underneath the bike, and force changes with its position. I've adjusted the preload for race sag. So you adjust it for race sag, and then whatever static sag is, it'll just be whatever it is. You can't get both points, and I'll speak to that in a minute. And then calculation, I needed about 20 kilogram wheel preload, and I think I put that calculates to about 36 shock preload. And so if I look at it now, I'll just go to, actually if I go back one, you can't go back when you're recording. So just talk about some bro science summary now. It's actually very difficult to get both points. So I calculated this, the static weight on the rear was about 105 kilos. And, you know, we read about this, how it's 10% under static load. and 10% of your 240mm wheel travel would give you about 24mm sag. And then bike plus rider is about 169 kilograms, and they talk about, you read about 30% sag on the back under race, so that would be 80mm. So basically you could ratio this. So you say I want 80mm for 169, and if I had 105, what would it give me just on a linear ratio? So 80mm times 105 divided by 69 gives you 50mm. So you see there, you can't get both points just on the ratio of weight alone. So just on a linear basis, it's very hard to get both points, and I'll show you that in a graph as well. So what I recommend you do is you calculate what spring rate you actually want. So the spring rate formula is on the left hand side of this screen, and so you've got your spring rate you can calculate, and I calculated 169 kilos race minus about 30 kilogram shock preload gives me about an 8.5 kilogram spring, which I put in. So I put in an 8.5 kilogram spring. I put on probably a little bit more preload than that, which says I need about 3.5mm nut tightening just to get my preload. Now, because of the slack in the system and all the rest of it, I recommend you just use your 3.5mm as a starting point, and then manually adjust to achieve your 80mm rear wheel sag. So as I said, just tighten your nut up on your shock, and then start manually moving it to get your actual rear wheel movement. So if I went back to my original spring of 6 kilograms or 6.5 kilograms, whatever it was, per millimeter, I would actually have to put 100 kilograms preload onto that to get the same 80mm sag. And so that's why, if you work through this one, what spring load do I need for my spring weight? So you get your race weight times your ratio of your leverage minus your spring rate times a set factor, and that comes out I need 94 kilos on that spring, which is about a 15mm shock tightening and shock nut tighten. So that's just not going to work, and I'll show you why it's not going to work in another graph. So if you've got a 6.5mm spring or a 6mm spring or whatever it is, you'd be putting 100 kilograms preload onto that just to get your race sag, and I'll show you why that doesn't work. So what you need to do is get the right spring for your weight, and then you can put the right preload onto it. Okay, so let's go to the next one. So here we've got the graph I did previously. So I did a graph like this when I calculated that I needed 8.5 kilograms a millimeter, which is the blue line. So the blue line is 8.5 kilograms a millimeter, and it goes through the x-axis here is the weight on the rear wheel, and the y-axis is the rear wheel deflection. So I'm trying to get 80mm deflection for my race sag, which was the blue point. So there was 2 points I calculated previously: the old 1/10th rule for static sag, which gives you 24mm, and the 1/3 rule, which gives you 80mm for the race sag. Now you can see that if I draw a red line through those 2 points, that is a really soft spring. And not only that, is you need about what's that? That must be almost 20, 40, 60, 70 kilograms rear wheel weight, which is 120 kilos or something shock preload that you'd have to add. So you have to add a massive preload on the wheel if you want a soft spring to go through these 2 points. Now I was thinking about this, probably this works in the dirt bike world where they do have very large travels with soft springs, and so if you had a massive travel with a soft spring and you could put a reasonable preload on it, well, it might work, but for the DR650 it definitely doesn't work. The shock, you can't match those 2 points. So what I recommend is you calculate the spring deflection or the spring strength that you need to match the 80mm, and then you work out the preload that you'd put on to get exactly through that point. The other thing about the red line, if you want to think about it, is once you leave your 80mm race sag, that shock is moving quite fast for every kilogram you put on it. So this thing's going to be bouncing up and down because it's actually got a very steep line. So you just put a small weight on it and it moves a lot. So that's another reason why you have to calculate the right spring for your race sag, which is the bike plus the rider. And you can't get 2 points. So now if I go to, I think I've summarized all my bro science findings. So the first bro science you might hear is you can adjust sag for rider weight using preload. Well, you can theoretically, but if you've got the wrong spring, you're going to have to put a lot of preload on just to get the right sag. So for the DR, get rid of that 6.5 kg/mm spring and get the right spring for your weight. Mine was calculated at 8.5 and it feels great now. And so get the right spring for your weight, and then the preload you put on enables the right sag for the right spring. Otherwise you're going to have to put too much preload on it. The next bro science is you should have 10% static sag and 30% race sag. Well, that's nonsense. You can't actually get through 2 points with your spring rate. Regardless of what spring rate you choose, you'll never get through 2 points. And so 10% is probably the wrong number, and it's probably too low. And as I said, that it's very difficult to match both the numbers. There might be somebody out there with a unique set of circumstances, which is a function of bike weight, rider weight, spring rate, and preload, but I doubt it. I think if you've got your race sag right, your static sag will be too big compared with the 10% number. So what I would recommend is set your bike up for your race sag, which is your bike plus your rider, and the static sag will just be an outcome. It'll be what it is regardless. The next point is I think I've accepted in my own mind that when I calculated that initial preload setting, that there was some slack in the system that I needed to take up as you're preloading the shock. And so when I calculated 3 mil and put on 3 mil originally, it just was taking a lot of slack out of the system. And so it is a non-linear force linkage, remember. There is some slack in the shock in the system as you're screwing the nut down. And so I think you will require to put slightly more distance on the nut than you might actually calculate when you're initially screwing it up. And so what I did was I used the calculation for the starting point, and then I manually adjusted it to put on some more distance for the nut, and that worked really well. It was quite a trial and error at the end of the day, but I think I got there. The next thing is the airbox in or out. I did it with the airbox in. Probably if I was to do it again from scratch, I might take it out. You can't get a C-spanner into the shock, and if you want a C-spanner into the shock, which would make it quicker, it's probably worth taking the airbox out. I did it with it in, with a flat punch, and in trial and error. I think I was about 6 times up and down on the motocross lift, and the last time I was, adjusting it only a couple of turns, a couple of small movements. If I had the C-spanner, it would have been much quicker to adjust it. And so in summary, get the right spring for your weight. That's the first thing you need to do. Don't think you're going to solve your problem with preload. Once you have the right spring, then you can put the right preload on. Ignore static sag numbers. Just set it up for your race sag, which is the 80mm. Set up for 80mm and set your preload to get that. And as I said, you might calculate a number for your initial preload, but I think there's some slack in the system as you start to put initial preload on. So I used it to set how far I need to screw it down just to get an idea, and then I manually adjusted to get the final number. Airbox in or airbox out, as I said, I'd probably take it out if I was going to do it again, but now I've done it, it's done.